everyone, let's solve today's daily Litco challenge question. So the question is easy and it is minimum time visiting all points. Okay, let's read the question together. On a 2D plane, there are n points with integer coordinates. Point I is equal to xi, yi. So this is a 2D plane and there are n points 1, 2, 3, 4, 5, 6, 7, 8. And integer coordinates points are xi, yi, right? So in all 2D plane, the points are x comma y, and I need to return the minimum time in seconds to visit all the points in the order given by points. So okay, got it. In the order given by points, so I will be given n points in order and I need to find minimum time to visit all the points. Okay, what does in order mean? I have not understood this yet, but I'll figure it out while I'm reading the rest of the question. So you can move according to these rules. In 1 second, you can either move vertically by 1 unit. Oh, got it. So it means that they are saying that I need to visit the points by order only. But so suppose if I want to visit to this point, I mean I can visit vertically, horizontally, diagonally. So I need to figure out the minimum path to visit to the point, all the points that are in order. Okay, so in 1 second you can either move vertically by 1 unit. Okay, 1 unit. So from 0 to 1 I can move to 1 second, or I can move from this 0 to 1 in 1 second, or move diagonally. So I can move from here to here in 1 second. In other words, move 1 unit vertically, then 1 unit. Okay, and you have to visit the points in the same order as they appear in the array. Yes, so this is what in order means. I need to visit in same order, and that makes the question easier. You are allowed to pass through points that appear later in the order, but these do not count as visits. Okay, so it's not that. So suppose if I want to visit from this point to this point, I need to visit it in order, but it's not that I cannot go back. I can go back to the point, right? You are allowed to pass through points that appear later in the order, but these do not count as visits. You are allowed to pass through points that appear later in the order, but this not. Okay, got it. It means that like I can go from here to here, and I can go here and then go here. But this point appears later in the order, right? If but I can still go to this point, and then I mean I can go through this. I can make this point as a way to go up there, but this will not count as a visit. I have to visit this point at last. Okay, so points are in this example 1 1. So oh, I thought that this green is also point, but only this looks like this. Only this red are the point. 1 1 3 1 2. What are the points? One is 1 1, this one, and another is 1 2 3 4. Oh, okay, so 3 and 4. Okay, this is the second point, first point, second point, and negative minus 1 0. Oh, so these are the 3 points. First I have to visit here, then I have to visit here, then I have to visit here. Okay, oh my god, I have taken so long to just explain this problem. One optimal path is 1 1 2 2 2, from 1 1 to 2 2 to 3 3 3 to 3 4, and from 2 3 to 1 2 to 0 1 2 1. Okay, got it. So time from 1 2 to 3 4 is 1 1 2 3 4 is 1 2 3 seconds, right? And here is 1 2 3 4 seconds, so total is 7 seconds. Okay, got it. So how can I find the least maximum path? That is the question. Interesting. Here, why is it 5? It would be easier if I could draw here. This lead code should have some kind of interface to where I can draw these figures easily. Anyway, thinking, like if I first saw this question, then how would I do this one? um from this point to this point, what are the ways? Then I mean I could go from 1 1 2 3 4. What are the ways to get from 3 4 to minus 1 0? What are the ways? So it's basically, actually, I need to find the distance, minimum distance from one point to another point, from that point to another point, right? That's the basically, like, even if I have like 1,000 points. 1,000 points means A, B, C, D, E, F, G, H. Then even if I have this number of points, then it means that I need to find, this is the case, right? I need to find the minimum distance from E to B, and then B to C, and C to D, and E to F, things like that. So basically this question, I need to find out how to find the minimum distance from one point to another point. Okay, so let's try to find this one out. How can I find the minimum distance from 1 1 to 3 4? So I can see that 1 1 to 3 3 4 is here and 1 1 is here. So from 1 1 1 and 3 4. Okay, so 1 means in x-axis, and 3 is here, 4 is here, right? So one simple way, if I just would go vertically and horizontally, then it would be 1 2 3 4 and 5, right? um Vertically, horizontally, vertically. I think that going horizontally, going diagonally wherever it is possible is the best way forward, right? Because um if I go vertically and horizontally, then 1 2 3 4, it will be like 1 2 3 4. But if I go diagonal, then it is just two seconds only. So instead of going through a long way, I can just take a straight path, just direct path. If I'm here, I can see here, so it is always diagonal, right? I do not see like this. So yeah, however, when it is possible, I should go to the diagonal path and then only go upwards, right? So that is one of my idea. So it means that 1 1 and diagonally goes to 3 3. So if I want to go diagonally, then it is always like, so what is 1 minus 3 minus 1 is 2, right? So 3 and 1 plus 3 is 3. So it is always that if I am going diagonally. So this might also happen 4 comma 3. I think that I should take what is the list of these two numbers, whatever is the smaller of these two numbers, and whatever is the smaller of these two numbers, right? So I mean to say that it might be 1 2 and 4 3, right? So where can I go diagonally? At up to which point can I go diagonally? So it means that I need to take the smaller number, right? 1 comma 2. So 1 and 2. If 1 2 is here, then because I'm going diagonally, so 1 2 3 4 1 2 3. No idea actually. Oh, actually I should take bigger number here. Take bigger number in the beginning and take smaller number in the last, right? So 2 plus 1 is 3. So it means that I can go up to 2 smaller number in, sorry, bigger number in start and smaller number in end point. So if I put bigger is 2, right? I'm doing this bigger and smaller because I need to add it, right? And so 2 and 3 1. So 1, so diagonally it can go until 1 point only, right? So it will be 2 comma um, what will 1 comma 2 be when I go diagonally 1 point upwards? It will be 2 comma 3, right? So 2 comma 3, I mean 1 plus 1 and 2 plus 2 comma 3, and this is 4 comma 3. So now this one of the point is equal, right? So now I cannot go diagonally more, because if I go diagonally more, then this is not possible. So now I have to go vertically now. 4 minus 2 is 2. Yeah, so that is my point here actually. So even if I'm going from 3 4 to minus 1 0, then let's see if this works or not, my algorithm. From 3 4 to minus 1 0, if I'm going there, then it is like, or actually it is the same, right? From if I go from minus 1 to 0 or 3 to 4, it is the same thing. So 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 first of all, actually I want to clear my this idea. Why do I need to take bigger number in start and smaller number in end point? That is just my instinct, but I want to follow through that instinct, because here I'm not sure what to do. So 1 2 to 3 4, why did I take the bigger number here and the smaller number here? Because I thought that from 1 and 2, so this is my 1 2 and this is my 1 2, and if this is my 1 2 and if I want to go upwards, then actually what I thought was this is what would happen if it was 2 1 2 1 to 4 3. Right, what would happen if it is 2 1 2 4 3? Then what would happen, like 2 is here and then 1 is here, and I mean it would be easier if I could draw and like if I could visualize, but maybe I could do that in pen paper. That would, I mean, my some kind of good instinct would come up maybe. Where's my pen and paper? Where did it go? I can't see it, and it's okay. I think I'll try to find a solution here for 2 minutes. If I don't find, then I'll go grab pen and paper. Well, let's try to visualize. So if there is 2 1 here and I want to go to 4 3, 2 1 here and not even 4 3. Okay, for example, let's take 2 1 here and then 3 4. 2 1 here and then 2 1 is here and then 3 4 is here, right? So maximum diagonal I can go is just up to this point, right? If I see visually, I cannot go more than that. Actually what I could do is 2 1. So if I'm going diagonally, then I'm just doing plus 1, right? So it will be 2 plus 1 is 3, and 3 1 plus 2, 1 plus 1 is 2, and then I cannot go any further. So instead of trying to find the exact number first on what step to go, I can just keep on adding, I guess. I mean, if I need to add, if end point is upper, if end point is above start point, then this is the thing, right? If it is above, then I need to add, right? I need to add to the then I need to go diagonally upwards. So add 1 to each. add 1 to xy, right? I mean, from 2 1 to 3 4, since this is up then this one, so I need to add 2 plus 1 3, 1 plus 1 plus 1 2. And then since this x is already, I mean, this is already equal, so I cannot go. So since this is already equal, so I can only now um, go from 2 to 4 vertically. So that's the point. And here also, since this end point is greater, so what I can do is I can just do 2 plus 1 3, 1 plus 1 2, oh 3 2, and then 3 plus 1 2, 3 plus 1 4, 2 plus 1 3. Oh this is just diagonal only. This is even easier. Okay, so this is even easier, but my algorithm is that just add 1 to xy. So go diagonal until until so if I get any point from if I go this from this point to this point, I'll go to its diagonal, right? Until this x or y becomes same. It means that if I'm at this point, suppose, and if I go to this point, then I would have gone diagonal until this is same, right? Until one of something comes in the same level. Because do you know what I mean? So if I'm at this point, then I would go, and if I need to go at this point, then I would go diagonal until I would hit uh, this line. But actually I'm not even sure if that would be the if that would be the if that would be the best path. Because sometimes, suppose, like, is going diagonal always the best path? That is my question. Suppose if I'm here and then I need to reach it at this point, from this point to this point, okay, then how would I reach from this point? From why am I making this problem so complex? 0 1, I feel like I'm giving too much. There is a very simple problem and then I'm taking too long. 0 1, and then oh, this is 1 0 1 0 2 0 1. Suppose, then what should I do? 1 plus 1 is 2, 2 plus 0 plus 1 is 1. So from this point I went to, because I was just adding, right, x and y, so I went until here 2 1, and then I should go here. So it is not always a good solution. One zero 2 0 1. Oh, this is 0 1 2 1 0 only. 0 1 2 1 0 only. So if I add 1 and then from this point 0 1, if I add 1, then I'll go to 0 1 2. I mean, how can I go from here, this point to this point? Like, it is like from 0 1 to 1 0. It is 1 minus 1, right? I need to add 1 minus 1. 1 minus 1. If I need to go here, then I need to add 1 plus 1. If I need to go down, then I need to add 1 minus 1. So there are different ways of going diagonal, right? So one is 1 1 and another one is 1 minus 1, another one might be 1 minus 1 minus 1, another one might be minus 1 comma 1, right? Like from this point, if I go want to go there, 1 1 1 minus 1 minus 1 1 minus 1 minus 1 1. But how will I know which way I need to go to? Actually, I feel like I have taken too long of a time, and I don't know why I cannot solve this easy question today. I feel like I want I need, I'm feeling like I need to look at editorial, and I want to give up. But sorry, but I don't know. Should I continue? Should I just look at the solution? I think that if I give it a little more time, then I can do it. I'm sure that it is not too hard. So, okay, I will give me time. I'll grab a pen and paper. Okay, I'll go to grab pen and paper. Okay. Okay, I bought a pen and paper. Now let's try to okay, now I will try to, so I will be silent for a few minutes, like up to 2 minutes, and try to figure it out on my pen and paper how I can solve this. Okay. So what I think is, I think that I was going on a right path. So this is the way to go, right? First of all, I'll just go diagonally and then go up, and then go vertically or horizontally to that point. So I'm not like thought about this algorithm totally, but I just figured that out, that I was going in the right direction. And so if I want to go, so I'm going diagonally in the beginning. So first of all, I need to know, right, which diagonal do I need to go, because there are 1 1 1 1 minus 1 minus 1 minus, there are 4 kinds of diagonals, right? I can go this way, this way, this way, this way. So how can I know? That is, I guess, from 3 to minus 1 it is. From going 3 to minus 1, since it is from positive to negative, it is I mean, I need to go negative, right? And from 4 to 0 I need to go negative as well. So that gives me the thing, right? So if it was 3 4 2 2 3, then it would be like, I need to go negative here. And then from 4 to 3, since it is 4 to 3, so I need to go negative here as well, actually. Negative only. But if it was 1 1 to 3 4, then from 1 to 3 also it is positive, and 1 to 4 is also positive. So I need to go positive positive. Is that how I need to do this? And from 3 to 2 minus 1 also, since it is from 3 to negative, so I need to go negative in x axis. And from 2 to 2 it is the same, it is just my negative 1 only then. Okay, very good. Okay, I will just write in my pen and paper again and then verify that this logic, because every logic that I am coming through, this is just in instinct, and I need to verify my instinct in pen and paper, because I cannot draw pen and paper here. I mean, I cannot draw the graph here. So okay, so what I was thinking is, I think it is working, right? Okay, looks good to me. So whatever I said, it looks good to me. Let's try to follow that. So my algorithm now is not this. It is now that algorithm is that I know that I can go diagonally. So I'm just assuming, okay? I know that the fastest way is to go diagonally first. How like diagonally first, wherever however much I can. After that, after that I can go vertical or horizontal. So I know that, and I know that I can go diagonally in four ways, right? So after that, what I will do is, if I have any number x1 y1 2, if I want to go any number x1 y1 to x2 y2, then what I need to do is I need to see if x2 is greater than x1, right? If x2 is if this is greater, then my diagonal diagonal dx will be equal to, oh my god, I'm getting so many messenger notifications, dx it will be equal to 1, okay? And uh, if it is equal, then dx will be equal to 1. Otherwise, if it is equal, um, if it is greater than x1, then dx will be equal to 1. And if x2 is less than x1, then dx will be equal to -1, right? Because I need to go to left, because this point is smaller. Otherwise, if they are both equal, then I do not need to go anywhere, so this will be equal to 0. It means that I do not need to travel, you know that. So it is similar for y as well. So if y2 is greater than y1, then dy will be equal to 1, and dy will be equal to -1. Otherwise it will be equal to 0, right? So this is it actually. So once I find dx, I mean, I'm not sure actually, dx. So after I find dx and dy, I don't think I need this. So whatever the case, once I find dx and dy, where to go, right? I think that I need to go to while loop right now. So I need to go to while loop until, if while x is not equal to x2 and y1 is not equal to y2. I need to go on, right? If they are both, if both of them are not still equal, I need to go to x1 is equal to, will be equal to x1 plus dx, and x1 will be equal to, and sorry, x2 will be equal to x2 plus dy, right? So I'm constantly updating x1. I'm constantly going this point. I'm constantly trying to reach this point, so I'm going this, and every time I do this, I will also add, so there will be one counter, right? So I will increment that counter every time, or counter second, or total number of second. So counter second will be incremented every time. So whenever this x1 or x2 and y or y1, one of these will be equal, if both of them are not equal, then I'm doing this. If one of them are equal, then I need to just if these two are equal, then it means that I need to go horizontally, right? So counter second will be added such a way that y2 minus y1. I'll also go through this case, but first let me write. And if x1 is equal to x2, I mean similar case, but okay, I mean I will optimize this code. So this is my rough code. Okay, so let's go through an example and then it will be easier to understand. So this is just for 2 points only. Okay, from 1 1 to, or let's say from 3 to, from 3 4 to minus 1 0. Okay, so if this is the point, if x1 y1 is equal to 3 4 and x2 y2 is equal to minus 1 0, then what will happen? So x2 is minus 1 is greater than 0, so my x2 is less than 3, right? So our dx is 3 in this case, because this is less than x1. So dx is equal to minus 1 in this case, and in this case it is decreasing. Y2 is less than y1, so it is minus 1, so both minus 1 minus 1, right? So in our example, both both dx is also equal to minus 1 and dy is also equal to minus 1. Okay, so let's see now. So I'm going from 3 4 to minus 1 0. So my x2 y2 is equal to minus 1 0 and x1 y1 is equal to 3 4. Okay, so now I'm going minus 1 and minus 1, right? So it will be 2 comma minus 1 is 3, and still it is not equal, right? X2 minus 1 is not equal to 2 and 0 is not equal to 3. So and after this minus 1 is 1 and 2, still both are not equal, and 0 and 1 still not equal. So counter second has already come from 1 to 3, so counter second has already increased to 3 seconds. Okay, and if it is minus 1 0, then it is easy, right? It will be 4, and then, but I want to change this example because this example is too straightforward. So suppose if it was 0 comma 2, then what would happen? Then in this case it would be, okay, now 0 and 0 they are equal, right? So this is false, so it will go out, because we already have one of the, because we already have come in one plane, right? This is same. So in this case, if one of these are already equal, then what I can do is, if this is the case, if x1 is equal to x2, then counter second will be equal to y2 minus y1, or what, yeah, I'm what I can do is method apps, because sometimes it might be negative or positive, right? If method f's of y2 minus y1, right? X1 equals to x2, then method f's y2 minus y1, y2 minus y1. Okay, so it will be 2 minus 1 1. So suppose if this is 0 1 and I want to go to 0 2 here, then it would be here 1, only 1 go up. But if this was the case, if x2 is equal to x2, then this would be the case. But suppose if this is the case, then it would be is equal to x2 minus x1. Okay, suppose if this was the same 1 and this is what was different, then it would be what am I doing? Suppose if this is the same, then it would be x2 2 minus 1 1. Okay, so this is going vertical, this is going horizontal. Yes, so So this is for the function of, and actually this is just for going from one point to another point, right? So I mean there are different ways to do this, but I guess what I can do is I can make this a function, maybe that might be more easier. And these are my points. So while total second is equal to 0 and 1 comma 1 comma 3 comma 4, right? This 2, and I can only go until -1, so it will be 0 1 2. I will only go from 1 to 3 3 4 and 3 4 to -1 0. I don't have to go to the end. And at last return total second. So points 1 and points 2, yeah, I can also do that, like point 1 and point 2. This is much, I mean, I guess it's easier for reading. So it's 2y2 dx. Why did time limit exceed? So 1 1 3 4, right? um so 1 plus 1 will be 2. So if it is 1 1 3 4, then it will be 1 1 2 3 4, right? So x1 y, so 1 plus 1 will be 2 2, and then 3 3. So x1 and x2, they are equal now, and it should exit. Why did it not exit here? I think this is where it is going the wrong. I think this is the condition where I'm not writing it properly. I always mess up with these conditions. So suppose if it is 3 comma 3 and 3 comma 4, then should it exit or not? 3 comma x1 is not equal to x2, but they are equal. Since they are equal, this should be false. So, right, so this, since this is false, it should exit, isn't it? Why did it not exit then? Oh, what am I doing here? What am I doing? But still it didn't work, because 1 1 1 3 4. So first of all, it is if it is minus 1 0, and if it is 3 and 4, then it's like first of all it will be 2 3, and I mean it should be, both should be equal, right? 2 3, I mean it will be minus 1 0 after some point. 1 2 0 1 minus 1 0, so both will be equal, so this will be equal. And oh, okay. Actually what is happening is, I did not think about, I thought that minus 1 0 and minus 1 0, right? So since they are both equal, and minus 1 minus minus 1, it is becoming plus 2. See, what I was trying to do here is, I was trying to do this, not that. So this is not working properly. um okay, I'll just write in my paper again. So this is 3, and this is 1 2 3, and 1 minus 1 minus 2 minus 3. I guess that was correct, but actually I forgot to do it here. Maybe that was the reason. What the? Why am I making such mistakes? Okay, so 67 passed, and for one, it exceeded the time limit. Okay, it was accepted now. So that's great. So the things that I was messing up was, after writing this algorithm, thing that I was messing up was I forgot to do method apps here. I guess this was causing problem as well, right? And there was a typo here. And okay, so everything was a typo, or uh, because I just wrote algorithm, right, this, and let's copy pasted, so many things were wrong. So what I should have done was, after writing code, I should have gone through every point to check if there is any typos, and if anything like this is missing, anything like this is missing, anything like this was like typos or not. So I did logical check, but I did not do syntactical check. So that was my mistake. And yes, that's all. mm, Thank you for watching. Okay, bye.